A train moving on a straight track. ಅಲ್ಲೇ ಬಂತಲ್ಲ, one dimensional motion. ಅದರ ಯೂನಿಟ್ಸ್ ನೋಡಿ, ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಇಲ್ಲ. ಫಸ್ಟ್ I have to calculate the retardation of the train. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. We have started our discussion on solving numericals from mechanics. Today we will continue the session and solve furthermore problems from the chapter Motion in a Straight Line. The first one, a train moving on a straight track. ಅಲ್ಲೇ ಬಂತಲ್ಲ, one dimensional motion. Motion in a straight line. With a velocity of 36 kilometers per hour is brought to rest. Very beautiful. Is brought to rest, traveling a distance of 100 meters. By applying brakes, calculate the retardation of the train, time in which the train is brought to rest. Have we done such problems in the earlier session? Very much yes. Now to collect the data, there is a train moving on a straight track with a velocity of 36 kilometers per hour. So initial velocity is given 36 kilometers per hour. ಅದರ ಯೂನಿಟ್ಸ್ ನೋಡಿ, ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಇಲ್ಲ. Here initial velocity is in terms of kilometer per hour. So I have taught you how do we convert this to meter per second. 36 into 1000 divided by 60 into 60, which is 10 meters per second. So the initial velocity of the train is 10 meters per second. And very clearly he says it is brought to rest. Rest andre final velocity is 0. So the final velocity is 0, traveling a distance of 100 meters. Now, first I have to calculate the retardation of the train. Negative acceleration aste. See, if you observe the data, nowhere time is coming into picture. So I have to go for an equation of motion which is independent of time. And from where retardation can be calculated. So we have v square equals u square plus 2es. the third equation of motion, which is independent of time. V square, final velocity is 0. 10 square plus 2a into 100, or this is minus 100 is 200a, or a is minus 0.5 meter per second square. So very clearly, because of this negative sign, we conclude saying that it is retardation. And I have also to calculate the time interval in which it is brought to rest. So an equation with time, V equals U plus AT, 0 equals 10 plus minus 0.5 t, or from this t is equal to, on simplification, 20 seconds. So very clearly, using the equations of motion and necessary conversion factors, I have arrived at the given solution. Next one. A body is projected vertically upwards. A body is thrown or projected vertically upwards with a velocity of 20 meters per second. So it is thrown vertically upwards with a velocity of 20 meters per second. I have to calculate maximum height attained by the body, maximum height reached by the body, time taken to reach the maximum height, and velocity midway during the upward journey. Now to collect the data, velocity of projection is 20 meters per second. So U is 20 meters per second. The body is thrown up. It is projected up with this velocity. And final velocity is 0 as the body attains or reaches maximum height. At the maximum height, we have studied the final velocity is 0. And here, A is minus 10 meters per second square, because it is upward motion. Body is thrown vertically upwards. First, I will calculate the maximum height that is reached by the body. Again, with whatever data I have, which is independent of time, I will calculate the maximum height. So again, I use B square is U square plus 2AS. where S now is the maximum height reached. So 0 square is 20 square plus 2 minus 10 into H. A is very clearly minus 10. Or this is minus 400 is minus 20H, or H on simplification is 20 meter. So very clearly, I have calculated the first part of the problem, which is the maximum height. Next, I have to calculate the time taken by this body to reach the maximum height. Again, time, V equals U plus ET. 0, U is 20 plus minus 10T. So minus 20 minus gets cancelled. So on simplification, T turns out to be 2 seconds. So easily again, by using the equations of motion, I have been able to simplify the first 2 parts of the question. The third one, velocity midway during the upward motion. The velocity midway. Midway andreno, half of the upward motion, as the body is attaining half of that maximum height. I say velocity midway plus 2 AS, or is U square plus 2A. Now this is H divided by 2, because we are calculating the velocity midway. Or this is V square M is 20 square plus 2 minus 10 H by 2. On simplification, this Vm turns out to be 1.42 meter per second. I expect you all, this is on simplification. I expect this to be 14.2 meter per second. So students, all these simplifications I expect you all to do since you have a calculator. I've given you the concept, I've shown you the substitution, arrive at the final result. The next problem, students. The same problem. So a body vertically upwards. Again, the body is thrown vertically upwards with a velocity of 15 meter per second from the top of a tower. Very interesting. Now the body is projected from the top of a tower with a velocity of 15 meter per second, reaches the ground in 5 seconds. So it is reaching the ground in 5 seconds. I have to find the height of the tower. Also find the speed with which it is hitting the ground, where G is 10 meter per second square. So the logic here is the body is projected up. It is thrown up from a tower. So I say, again the action is happening against gravity. Yes, is minus h. It is thrown up, projected up from the height of a tower. Again, A is minus G minus 10 meter per second square. And the velocity of projection is 15 meter per second. So with this, I have been asked to calculate the height of the tower. Again, distance is mentioned here. I don't know the final velocity, but I know the time it hits the ground in 5 seconds. So I use the equation. S equals ut plus half gt square. Now S is minus h. U is 15 into 5 plus half minus 10. T square is 5 square minus h, 75. This is minus half, 10. So when you simplify, minus and minus gets cancelled. Height of the tower is 50 meter. Now I have to also calculate the speed with which the body strikes the ground, which is V equals U plus AT. V is equal to 15 plus minus 10 into 5. So the answer is minus 35 meter per second. This simply shows the direction that is acting downwards. So we arrive at the answer. This means it is showing opposite to the direction of propagation or projection. So if we analyze back the simplification, so this is 5 square 25. So 25 into 10, 250 by 2, 75 minus 25, which turns out to be 50 meters. The next one. So the same way, the same problem, we will just change the data. Now I say this is an assignment problem for y'all. Again, S is minus h. Again, velocity of projection is 25 meter per second. I say T is 15 seconds and A is minus 10 meter per second square. The same thing has to be calculated. First, S is UT plus half GT square minus H 25 into 15 plus half minus 10 15 whole square. Calculate H. This is only a purpose that you adhere to simplification. I have just changed the data. Numericals, concepts remain same. Again, B, U plus AT. Again, B has to be calculated. Plus, again, you have a negative sign just indicating downward motion. So we have solved few good problems from motion in a straight line. Next session, we will progress with few more problems. Until then, practice these sessions, become thorough, come prepared for the next class. Have a nice time. Thank you.